Hello, in this video we're going to learn the end behavior and leading term of a polynomial function. For a large value of x, either positive or negative, the graph of the polynomial function p of x a n to the x minus x to the n plus a n minus 1 x to the n minus 1 and so on all the way to a0 resemble the graph of the power function y equal a n x to the n. For example, if you have this function negative x to the fifth plus 2x squared minus x plus 11, then the graph of f will behave like y equal negative x to the fifth for a very large value of x. So if x is 100, the graph will behave just like negative x to the fifth, because a negative 100 to the fifth, negative 100 to the fifth is a lot larger than the rest if we plug it into 100 squared minus 100 plus 11. So the graph will take the shape of negative x to the fifth. So either positive or negative. So I choose 100 to be negative, the same with a negative 100. The end behavior of polynomial function p of x is determined by the degree n and the sign of the leading coefficient. So the degree and the highest degree and the sign of the leading coefficient, so either negative or positive. And here is the summary of how basically would behave. So if an, which is the leading coefficient, is positive, it will look upward this way. So if an is positive and the degree is odd, for example, if we have x to the fifth, and here I have 2, the leading coefficient is positive, and then the highest degree is odd, here we'll have negative 2 x to the fifth. So again, to understand the end behavior, you just try to plug in a big number here, and remember, in this side will be negative infinity and x here will be positive infinity. For example, you could just think of number 10 is big enough, or 100, and see what's gonna happen. Negative 100 and 100. So if we have a 10 to the fifth, it's a larger number, you multiply it by 2, so it's going to be another positive number. But if I plug it in with x negative 10 to the fifth, then it's going to be a negative number, and you multiply it by 2, that will be still a negative number. So it's going to be a negative, or closer to going toward a negative infinity, because here is negative infinity and here is positive infinity as well. And the same in here. So you don't need to memorize the shape, but just think about it as if x is 10 and if x is negative 10, you plug it in the numbers and see how it's going to behave. Is it going, when x is negative 10, is it going to go be a positive number or a negative number? If it is positive number, that means it's going toward a positive infinity. And if it is a negative number, it will go toward a negative infinity, like this one here, going toward the y value is going toward the negative infinity. So if y would be minus 2, and then if I choose x to be 10, then it's going to be minus 2 times 10 to the fifth, and 10 to the fifth is a larger number. You multiply it by negative, that will give you closer to negative infinity. And for when a is even, when n is even, we'll have, for example, 2x to the sixth or negative 2x to the sixth. So again, we use the same thing. So either is going to be looking both of them up, and the reason is that this is an even. So positive or negative, the whole thing in here will be an even number. So you multiply it with a positive, it will be looking up. What determines here is the leading coefficient. if the leading coefficient is negative, and this one is always positive, so you multiply positive with negative will be negative, and that's why it's going to go toward a negative infinity. It will be a negative number. So let's see this example here. Determine the end behavior of the polynomial. I know I have the graph here, nicely done, but if I didn't have the graph, I would know that it's odd. I ignore the rest, and I just look at negative y equal negative x to the fifth. So I know that if x is negative 10, then I will have y equal minus 10 to the fifth. So this in here to the fifth, it will be a negative number, and you multiply it with another negative, so the answer will be positive number. So when x is a negative 10, for example, all the way here, then the value of the function will go towards some positive infinity, and that's why the graph is right here on the positive side. And when x is positive 10, for example, if x equal 10, then the behavior of the function would be taking the behavior of the just negative x to the fifth, so 10 to the fifth. Again, 10 to the fifth is some positive number, many zeros, 2, 3, 4, 5. And then with the negative up front, so this is almost going closer to negative infinity. So that's why the y value is going toward a negative infinity. So this how we study the end behavior of a polynomial function. We just focus on the leading coefficient and the highest degree, even or odd. If it is even, both of them are either gonna look up or both down. It depends on the leading coefficient. And if it is odd, then it's gonna, when it's a negative, we will negative times a negative will go toward to positive, and so on. And I hope this video is helpful.